Alright, working on Module 6 still. Number 7. What I'm going to do is change some of the wording in the problem to make an example. So, a sample of 400 devices, and 25 are defective. How many would be defective out of 3,000? So I'm not just changing much, I'm just changing a couple of things. So what we're going to do is I'm going to set up a proportion. Okay. So I'm going to talk about the defective of the total. So the first information, I have a sample of 400 devices and 25 are defective. That's where I'm going to stop my reading. I'm going to set up a fraction. My total of 400, 25 of those are defective. So I'm setting up a fraction to say how many out of the total are defective. Now, I'm going to compare that with a larger amount of 300. So I'm going to set it equals. I'm going to set up a proportion, and I'm going to set up another fraction and do some cross multiplying to give me an estimate. How many would be defective? So I don't know. That's the question mark. So I'm going to put defective for this bunch is going to be X. And now this time, instead of the total of 400, I'm comparing it to 3,000. So in your problem, when you do this, it's the exact same setup. Just figure out where your numbers go from. Now, something to double check on. When you look at the numbers on the bottom, these are both like totals. This is like a mini sample, and then this is a larger sample. If 400 is in here and 3,000 is over here, well, the top numbers kind of work on the same way. If I go from 400 to a bigger number of 3,000, then I start at 25, and this number X should comparably be larger than 25. So when we do this, hopefully it'll work. Alright, so what I'm going to do now is cross multiply. I'm going to multiply those two together. And this is only done when you have equations with fractions and equal signs. It's just kind of like a shortcut to get rid of the fractions. 25 times 3,000. Equal sign comes down, but no more fractions. And yeah, I cross multiply the other diagonal. 400 times X. So what happens is, I do 25 times 3,000. I get 75,000 equals 400x. And I solve for x. So divide by 4,000. A little trick here is if you have zeros at the end, one on top, one on bottom, cancel. One on top, one on bottom, cancel. If you typed it in the other way, it should work out the same. So approximately 187.5, or we'll say almost, because we can't have a half of a device and say if it's working. And so that's why I'm rounding. I'm rounding up to the nearest device. So almost 188 will be defective. Now, if your answer does not end in a decimal, then you don't need to worry about it. So set up your problem similar to this, cross multiply, and see what you get for how many would be defective out of the problem they gave you. And problem number 8, I'm going to help you with the setup. Okay. Now, Mary can paint one room. It takes Mary 100 minutes to paint a room, and it takes Jake 150 minutes. So I'm going to work in everything in terms of minutes. So if I have 1 hour, so 60 minutes for Mary out of the 100. So that's Mary's side. Jake has 150, oh, I'm sorry. Jake has 60 minutes done of the 150. I'm going to reduce these fractions. So 60 out of 100 reduces to 3/5. 60 out of 150 reduces to the fraction of 2/5. I'm going to put a variable x with both of these because together they are going to paint one room. So her time plus his time, and they are trying to paint one room together. So what I'm going to ask you to do now is add these two fractions together, make sure the denominators are the same, which they are. So 5 out of 5x equals 1. So this is 1x. So x is 1. So together, in this amount of time, they painted one room. So how much time did I talk about? Okay, and this, it may seem easier and you may second guess it, but it is basically how much time went by, how much time did we talk about would go by that they would be painting a room together.